I'm here to talk about how to edge cache GraphQL APIs. My name is Max, and I am the co-founder of GraphCDN. Now, what most people know me for, like I said, is my open source work. I've done a bunch of open source work in the React and particularly in the React ecosystem, but in the JavaScript ecosystem generally. And a while ago, 3-4 years ago, I was actually building a startup, and this is really where my GraphQL story started, because we were using GraphQL for our entire API needs at Spectrum, which was the startup I co-founded previously. And we were building this modern take on a community forum. So essentially, we wanted to take what PHP started 20 years ago, but make it modern again and make it a unified platform. And we were using GraphQL for all of our API needs. And I was the CTO, and we were building this platform out, and we had huge scaling problems because more and more users just kept visiting our product and kept finding it, and our servers and our infrastructure could not keep up. And if you think about sort of a forum, it's really the ideal use case for caching, because all of your data is public, or almost all of your data is public. It's the same data for everyone. It doesn't change, right? Like when you're looking at a post, it doesn't change who's looking at it. It doesn't change what's in the post, right? If you're looking at the comments, those don't change either. And so in my head, I was like, well, we have all of these infrastructure troubles, but really we should be caching our API, right? Like we have all of this data, and we had some database level caching, of course, but still we were having infrastructure troubles. And I was like, well, if only we could cache our GraphQL API, then we could really alleviate a lot of the load of our servers. And in my head, even I remember talking to my co-founder, and I even asked this question, like, why can I not just take a GraphQL client, like Apollo client or Urkel or Relay, and deploy that on a server somewhere, right? Rather than caching on the client, I want to cache stuff for all of the clients, just at the server level. And this is really where all of this started. Now, first, let's talk a bit about how actually GraphQL clients cache, because just like the GraphQL code generator that Lucas just so beautifully demonstrated, this is another great example of where the schema of GraphQL is super helpful, and the fact that it's strictly typed. Because the way it works is that when you're looking at a GraphQL query, like here we're looking at a GraphQL query that fetches a specific post based on its slug. And it's loading its ID and title and its author with its ID, name, and avatar. And the real magic, sort of the fairy dust that makes all of this work, is the __ type name meta field, which we can add to any GraphQL query and any object within that query. And the power of that is that it tells us what the type of this thing is, which might sound trivial, right? Of course, when I'm loading a post, I get a post back, and when I'm loading its author, I get a user back. But the client and anybody in between usually doesn't know that. And so with this __ type name field, which any GraphQL API exposes automatically, the result we get back tells us, hey, you've loaded the post with the ID 5 and the user with the ID 1. And they're connected in this way where you have the post and the author of the post is the user with the ID 1. And that's really the magic that makes GraphQL clients so powerful, because when they see this response for the query and they see, okay, we've loaded the post with this ID, we've loaded the user with this ID, they can take this entire response blob and they can put it into the cache. And the next time the same query comes around, they're like, wait, we're loading the post with the slug GraphQL caching. Well, I know how to get you that. We don't need to go to the server. Here's your result, right? And that's really what makes it so powerful. Even more powerful is when you start working with mutations, because GraphQL sort of differentiates between queries, which just load some data, and mutations, which change some data. And because we know that a mutation passes through the cache, we can then know, hey, look, we have an edit post here, for example, that edits the post with the ID 5 to have a different title, how to edge cache GraphQL APIs. Again, we can add the type name field to our mutation response. And then when that response comes back, it tells us, okay, you just sent a mutation. And from that mutation, you returned the post with the ID 5. Hold on a second. I remember I had this query in my cache that also contains the post with the ID 5. Sounds like I might need to invalidate that. And because we know, oh, this was an action that changed something versus, oh, we sent a query that actually fetched something, we can suddenly analyze which changes move through our GraphQL API and update the cache very efficiently and invalidate when we need to. Now, GraphQL clients actually sort of stop at a certain level, which is list invalidation. One of the most, I would say, maybe even annoying parts of working with GraphQL caching is that mutations only work for updates and deletes, but they don't work for creates. And there's a very specific reason for that. If we have a query of posts, so multiple posts in a list, and we get back the response, in this case, we just have one post in our list, again, the post with the ID 5, and then we have a mutation that creates a new post. Now, this creates a completely new object in our database with a completely new ID and also otherwise completely new data. When that mutation response comes back from the API, it doesn't really tell us anything because it tells us, hey, the post with the ID number 6 has changed. But of course, the post with the ID 6 isn't even in our cache dataset, right? We've never seen that post before. All we know is it came back from this mutation. And the GraphQL client basically cannot automatically invalidate our list of posts because there's no post with ID 6 in there. And so what you have to resort to is manual invalidation. And for example, with Urkel, which is my personal favorite GraphQL client, if you want to get into controversial topics again, you can specify these updates based on certain mutations. And for example, in this case, I can configure Urkel to say, hey, anytime a create post mutation comes in, please invalidate any posts query. So invalidate that query that we send to get the list of posts anytime a new post is created. And then the next time that query is run, rather than serving the result from the cache, it'll actually fetch the fresh result from the server, which includes our new post, the number 6, with the number 6. And that's sort of how GraphQL clients work by default. And then there's sort of a more advanced mode. And that more advanced mode is called normalized caching. Personally, I think normalized caching is a bit of a terrible name because I think the name relational caching would be a lot more obvious. But essentially what it boils down to is that rather than caching entire query results for entire queries, they actually take out every single object and normalize it down into a relational structure. And so if we go back to our get post query, which returns the post and its author, and we look at the response, right? We have the post with ID 5 and the user with the ID 1. We've seen this before. Rather than taking this entire thing and putting it into the cache, with normalized caching, you're actually storing each object individually. So in this case, our cache data will actually have a post with the ID 5 that refers to the data for the post with the ID 5, and then the user with the ID 1 as a key that refers to the user with the ID 1. What's missing here, of course, is post.author, which is what connects the post to the user. And so there's a second sort of storage mechanism which connects all of these relations, and it tells the GraphQL client that the query for the post with the slug GraphQL edge caching is the post with ID 5, with its data sitting in the other object, and the post with the ID 5 has an author, which is the user with the ID 1. And that's sort of how it has its own relations table almost. This is literally a little bit like a database. You store each object with its ID completely separately from its relations, and you sort of connect them back together at the end. And the reason GraphQL clients do this is because it actually makes for a much nicer user experience. Because if I know, for example, from a mutation, like we saw before, that the post with the ID 5 has changed, I can now update it in this one central place where I store what even is the post with the ID 5. And any query that has ever fetched that post will be updated automatically. And so the cache can basically update all of the queries at the same time, which is a lot more efficient. And also, where you'll notice this in apps that use GraphQL is mostly with lists. So if you have a list of posts, and then you click on a post, if the GraphQL client uses normalized caching, it can know that it's already fetched the data for the post to display it in the list, right? And so it can actually serve the result of the sort of get a single post query automatically on the client, and then you only have to load whatever else you want to show about the post, right? Like the comments maybe or the likes. And so it makes for a really nice user experience and for a much smarter caching experience. Now, to go back to my original plan, I essentially wanted to take a GraphQL client and deploy it to the edge, right? Ideally, because the world isn't Virginia, right? Most people host their servers in Virginia, in US East 1. It's like the standard place where you put your new servers. But the world really isn't Virginia. I'm in Austria. I have colleagues in Australia. I have a lot of friends across the entire globe, right? And really what I wanted to do is I wanted to distribute our data worldwide so that everybody could access it super quickly. And it should also be cached because I don't want to handle every single request from my server in my database because the data is the same for everyone anyway. So that's where GraphCDN comes in. At the time with Spectrum, this didn't exist at all. And even nowadays, it didn't exist. And so about a year ago, Tim started working on the first version of what became GraphCDN, which is essentially a GraphQL edge cache. And it's not quite as simple as I initially thought. You can't literally take a GraphQL client and deploy it to the edge. It's a little bit harder than that because you have different constraints. Because if you think about what GraphCDN has to do, it's a CDN, so it's a proxy, it's a gateway that sits in between your GraphQL client and your GraphQL API. And it caches stuff at this sort of CDN level. And it does the caching sort of similar to GraphQL clients, and then it also does the purging. But the problem is, GraphCDN, when you're writing a GraphQL client, you can assume that it's always for the same user. So you don't have to worry about authorization. If data comes back from the API, you know that the client is authorized to see it, so you don't need to check anything there. You can just keep serving the same data from the cache. But if you're a proxy, if you're a gateway for GraphQL, then you can't assume that because two requests might come in from two different users, or maybe even the same user, or maybe there's like 5 different users accessing the same data, and you don't automatically know who has access to what. And so that's why you can't quite take a GraphQL client and deploy it to the edge, but we sort of had to build our own caching mechanism. Now, we built this caching mechanism and it actually works the simple way. So it takes an entire query and it stores the entire query result. It doesn't do any of the normalized caching because of that constraint, right? We don't know that every person that requests it has access to the same post with the ID 5. We can't just automatically assume that because we're a gateway. And so lots of different users are querying through us and our cache is serving to lots of different users from the same location. Now, we also know that building a CDN is super duper hard. Building out all of this infrastructure in all of these different locations all around the globe is a ton of work that we're honestly not very qualified for. So instead, we used Fastly's Compute at Edge product. And what Fastly essentially gives you is access to their infrastructure. So nowadays they have about 60 data centers spread all across the globe, and you can run your own code there. And it's super fast and it's extremely, extremely powerful. And so we wrote all of this caching code to make caching work for sort of at the gateway level. And then we deploy it to Fastly's 60 locations. And if you use GraphCDN as a gateway for your GraphQL API, we'll route to the nearest gateway. So for me in Vienna, I know we have a data center in Vienna, and it's just going to use the data center in Vienna. If you're in Germany, it's going to use a data center in Germany. If you're in the US or in South America, it's going to use one. Whatever data center is closest to you. And because we're caching the data and we're serving it super close to the user, it reduces the response time for queries massively. So usually, if you, depending on how close you are to the data center, of course, if you're in Siberia, where there's not a single data center because not a lot of people live there, then it's going to take a little while longer to go to the data center in Finland, I think is the closest one. But since I'm in Vienna, for me, it's super fast, and usually it takes about 20 milliseconds. That's 20 milliseconds to get an API response back from the cache, which is crazy because even the fastest GraphQL APIs I've seen out in the wild take at least 500 milliseconds to serve responses usually. Now, I've blabbed a lot about GraphCDN. Now comes the risky part. I'm also doing a live demo, and I'm going to try to sign up to my own product and give you an example of what it feels like to use it. So I'm going to create a new service for a product that I built called ChangeFeed, which is one of my side projects. And that also uses GraphQL and it exposes a GraphQL API. And I'm going to create a new GraphCDN service. And then this will spin up sort of instances of GraphCDN in all of these 60 locations. And then I have a proxy, a gateway through to my GraphQL API. And I'm just going to write a very simple query here that doesn't even fetch any data because I'm too lazy to figure out how to fetch data. I'm just going to query the type name. And this goes all the way to my product's GraphQL API. And of course, it's a cache miss because GraphCDN hasn't seen this query before. But now it's actually cached at my local edge location in Vienna. And when I run this query again, it is super fast. It only takes 21 milliseconds to load that same data, and because I get a cache hit. And that's really where the power comes in. You can literally plug this into your GraphQL API, and you only have to change the URL that your GraphQL client fetches from, and suddenly you get all of this caching for free. Now, we've, of course, also done the mutation purging, where if a mutation comes through, we purge it. And we even have a manual purging API, which is, of course, also GraphQL, where you can manually purge stuff. So you have all of these mutations here to purge a user, purge a change, purge an up, purge a release, whatever you want, whatever types you have in your GraphQL API. You can then purge specific users, specific whatever types you have in your GraphQL API. And because we were in this, we built all of this caching logic, and then we were like, wait, we see every single GraphQL query and mutation that comes through our gateway. Why don't we just provide analytics for people, right? And so we've also built GraphQL Analytics. Now, this is demo data because I just created this service. So this is not, I'm not exposing any real data here, but this is what you would see, right? You would see your requests over time to get sort of a broad overview over how many cache hits and cache misses you get. You can see how fast or slow is my server usually. This is quite a slow GraphQL API with 1.3 seconds P95 response time from the origin. But then you can also dive into specific queries and mutations, right? And I can look at, okay, which queries and which mutations am I seeing how often? What's their cache hit rate? How fast are they? How slow are they? I can track my errors. I can see all of my GraphQL and HTTP errors that go through the gateway. And then a bunch of other stuff as well. Anyways, that's really what we built and what I wanted to show today. Thank you so much for having me. I hope you enjoyed this talk. I hope you learned something about GraphQL caching, and I look forward to learning more about Apollo Federation.
All right, so let's move to discussion, and let's hope we get some questions. I think it's impressive what's built, because there is potential to speed up GraphQL implementations a lot. That's a really good thing.
Thank you. I wish this existed 3 years ago when we were building Spectrum. I literally just went, what if this had existed, I would have used it instantly, and it would have solved all of our problems. And so now I was like, well, I kind of want to solve this problem. It's a really big problem, and I know we can help people.
I actually have a question. But Lucas, go ahead, please.
I definitely have to try it out. I haven't known it before, and it's super awesome. It's like Google Analytics on steroids for GraphQL. So alone for the performance insight for the individual queries, insane, really. That's what you need. You want to get those insights. And the performance is just, 21 milliseconds. It's like crazy.
We looked up recently, and on average, across the billions of requests that have passed through our gateway, we speed up GraphQL APIs at a P95 time by about 150x. That's like an average. That's an average speed up across across all of the requests we've seen, which is absolutely bonkers to me. Like, you just put us in front of your GraphQL API, you cache some stuff, you get 150x improvement in your performance. What? How is that? That doesn't even make any sense.
But I really like that you're using Fastly, because Fastly is really awesome.
I mean, shout out to Fastly, right? Like, we could not be doing this without it. Spinning up all of this infrastructure and making it this performant is an extremely hard problem. And I'm really glad that Fastly built Computed Edge, because it made our life so much easier. And we don't even have to worry about scaling, right? Like, people can throw however many requests they want at us. It's Fastly, right? Like, Fastly is going to be able to handle any traffic you throw at it. And so I don't have to get up at night due to a PagerDuty alert because our infrastructure is crashing, our servers can't handle it. I know Fastly can handle it.
I just chime in. I have a question, actually, because you said it's caching with the type name and the ID, right? But what if sometimes you have 2 primary keys, right? And it's, I don't know, an ID and something else. What do you do? How do you save it?
Great question. So both GraphQL clients and GraphCDN let you specify something that's usually called key fields. And essentially you can say, hey, for example, in our post example, right, the slug of the post is very unique. And I can tell my GraphQL client and also GraphCDN and any other cache you have, hey, posts are keyed by ID, but they're also uniquely identified by their slug. And then they have some special data structure under the hood that sort of says, okay, if I see the slug X, it refers to the ID Y, right? In our example or earlier, it was like, if you see the slug GraphQL caching, that refers to the post with the ID 5. If you have that in the cache, serve it, otherwise get it from from the server, if that makes sense. But that's very configurable. And again, is a big part of what actually makes GraphQL awesome is that it's so tightly specified. And it's surprising to me, and I didn't realize this for a long time, but that's exactly why the ID type exists in GraphQL, right? ID is its own scalar type, its own sort of primitive within the GraphQL specification. And that's actually the reason, because an ID, yes, it could be a string, it could be an int, but really what's important about an ID is that it's unique. And so that already tells GraphQL clients, if you give them the schema, that which are the key fields, right? Because ideally you would have an ID on your Slack field and on your ID field, if that makes sense.
So I have a couple of questions from YouTube. Is it available? Is this available for on-premises environments? So it's supposed, yeah.
That's one of the questions we get asked the most, and it's not currently because we're based on Fastly. We very explicitly decided to make sure that we can host this thing at a very high scale before we would even think about on-prem environments. We at first honestly didn't even know if we could make it work, because we started building this and we're like, wait, GraphQL caching actually, if you're doing it at the gateway level, is a little bit more complicated than we thought, right? And so it took us a while to get it right, and Fastly really is a super nice partner because, again, they can handle any scale. I know that some companies have requirements to deploy all the infrastructure on-prem, so that's definitely something we're thinking about, but it's not currently possible.
Yeah, sort of related. Why use Fastly and not something else like Amazon and these big dogs?
Because Fastly has more locations, and really what makes Fastly special is the purging. What I didn't really get into, and what is another big part of what makes GraphCDN special, is the super fast purging. If we see a mutation that tells us, hey, the post with the ID 5 has changed, we invalidate any cached query result that contains that post in 150 milliseconds globally. So literally, within 150 milliseconds, every single of the 60 locations all around the world won't have that cached stale data in their cache anymore. It'll be purged completely. And no matter where your users are, they'll go to the origin again to fetch the new data. And that is extremely powerful. And that is a big reason also why we use Fastly, because Fastly's purging is above everybody else. Like literally, if you think about any other CDN provider, any other infrastructure provider, yes, you could build this yourself, but there's no way you're building this yourself in any serious amount of time, because getting that down to 150 milliseconds is absolutely bonkers.
Yeah. So I think that's it for YouTube questions for now. We can take more, of course, if you have something in mind, because normally what happens is that we go to the next demonstration and then questions come to mind.
I have one question just to make sure everybody could understand it. So you said it's 21 milliseconds, right? If you have a one direction. Should we disable now local caching, and why not?
That's a great question. I don't think you should, because the local caching does make for an even nicer user experience. Like, it's just instant. And there is a difference between instant and 21 milliseconds. But at least for the initial fetch, the 21 milliseconds is a lot better than 1.5 seconds or even more, right? But I definitely think that local caching makes for a great developer experience. And honestly, it doesn't really come at any cost. In fact, if you use GraphQL CodeGen and you combine it with the Urkel plugin or the Apollo plugin or whatever your favorite GraphQL client is, use Urkel. Then you get an amazing developer experience, but also on the other side, you're getting an amazing user experience for all of your users.
All right, thanks.